Hi again. In the first video, we covered how to compute the dot product using the basic formula and how it relates to this nice easy formula using the product of the components added up, and how we could use that to then solve for the cosine and get the angle between the vectors. In the second video, we're going to talk about how to find the projection of one vector onto another and how to test to see if two vectors are perpendicular or orthogonal in the language of higher dimensions. Okay, so first of all, looking at this right here, the projection of u onto v, what that means is you're looking for the component of the vector u, which is in the direction of the vector v. So we drop that perpendicular, and then we look at this vector right here, that red vector. That vector is the projection of u onto v. To make that slightly more obvious, maybe look there. It's that vector that I just highlighted in orange. Okay, so that's the new vector. To find it, we just use this formula. And if you look at it closely, you realize that what's in parentheses is just a scalar multiple. It could be more than one or it could be less than one, but it's a scalar multiple of the original vector v. Okay, so let's do that. Let's find the projection of u onto v. So that means we'll have to do u dot v, which is equal to, here's u, and here's v. So we will have 3 times 2, which is 6, plus negative 2 times 0, which is 0, plus 8 times 3, which is 24, divided by, and then we have to do v dot v. Now v dot v is really the same as the sum of the squares of the components of v. Okay, so it's going to be 2 times 2, which is 2 squared, plus 0 times 0, which is 0 squared, plus 3 times 3, which is 3 squared. Then we're going to multiply that constant times the original vector for v, which was the vector 2, 0, 3. So we just have a fraction of the original vector, right? We've got 30 divided by 4, and 9 is 13, times the original vector 2, 0, 3. And now you could leave it like that if you want. If you wanted to, you could distribute the fraction through and make it 60/13, comma 0, comma 90/13. And that's the projection. That's this red vector right here. That's the amount of u that's going in the direction of v. Okay. Now, just to be clear, if you did the opposite, if you did v onto u, that would be a vector over parallel to u. So the formula would give you a different vector. Okay, so now we're going to look at how to test if two vectors are perpendicular or orthogonal. So I want to know, is u perpendicular to v? Is that true? And the answer is no, since we already know that u dot v is equal to 30, and that's not 0. So the answer is big fat no. Okay, is v perpendicular to w? Are they orthogonal? I don't know the answer to that one yet. We got to find out. So let's check. V dot w is the vectors 2, 0, 3, dotted with 6, 1, minus 2, which is equal to 2 times 6, which is 12, plus 0 times 1, which is 0, plus 3 times a minus 2, which is a negative 6. And so that's equal to positive 6. So that, as you already know, is not equal to 0. And so you would say, nope, v is not perpendicular to w. Exclamation mark. Okay, we have got one more to check. Is u perpendicular to w? Well, again, we don't know. We haven't checked that one yet. So we check u. U is equal to 3 minus 2, 8. And we try the dot product with w, which was 6, 1, and minus 2. And we see what we get. 3 times 6 is 18. Minus 2 times 1 is minus 2. 8 times 2 is minus 16, which is 18 minus 18, which is 0. And so the answer is yes, since the dot product is 0, so since u dot w equals 0, u is orthogonal to w. So that means that u and w, even though they're in three-dimensional space, are going to make a 90-degree angle when you measure them. All right, thanks very much. Bye.